In this next skill, which is trig identities, we will start by simplifying basic trig expressions. In level 1, we will be using reciprocal identities and quotient identities. Since cosecant is the reciprocal of sine, we could write cosecant as 1 over sine of theta. Secant is 1 over cosine of theta, cotangent is 1 over tangent theta. And then the quotient identities are that tangent is sine over cosine and cotangent is cosine over sine. So, to simplify a trig expression, looking at our first example, we can rewrite cotangent theta as cosine theta over sine theta. So to simplify this expression, I get sine theta times cosine theta over sine theta. And my sine thetas cancel. So I just end up with cosine theta. In the next example, tangent squared theta times cosecant squared theta. Tangent squared theta could be rewritten as sine squared theta over cosine squared theta. And cosecant is 1 over sine, so cosecant squared would be 1 over sine squared theta. One side note, when we square a trig function, like for example sine squared theta, that means sine of theta squared, but we don't write the exponent on the outside, we write it after the trig function, so it doesn't look like we're squaring the theta, because it's the whole expression squared. Okay, back to part B. The sine squared thetas will cancel, and I get 1 over cosine squared theta. But I can simplify that a little more because 1 over cosine is secant. So one of my goals is going to be to write these without quotients if possible, or without division not being in a fraction. So I can rewrite this as secant squared theta. In the next example, cotangent theta over cosecant theta. Cotangent theta is cosine theta over sine theta, divided by cosecant theta, which is 1 over sine theta. Now using my fraction rules, when we divide fractions, we multiply by the reciprocal of the second fraction. So this is really cosine theta over sine theta times the reciprocal of the one we're dividing by. So we end up with sine theta over 1. The sine thetas cancel, and we just end up with cosine theta for our simplified expression. And one last example, secant squared theta is 1 over cosine squared theta. Cosecant squared theta is 1 over sine squared theta. And to divide these, I get 1 over cosine squared theta times the reciprocal of the bottom fraction, sine squared theta over 1. And top times top, bottom times bottom gives us sine squared theta over cosine squared theta. And sine over cosine is tangent, so this would be tangent squared theta.